What is up, Five Keys? Mr. Mike here. It is Monday, February 7th, 2022. For me, it's the morning. You know how I am on Monday mornings, but I'm going to try my best to get excited for you. So it's Module 3, Lesson 3 day. In addition, Module 3 has been all about inequalities, and Lesson 3 is going to be about simplifying or solving these inequalities with multiplication and division, which is not dissimilar at all to solving equations with multiplication and division. There is only one thing that gets a little bit different and a little bit complicated. So I want to point it out to you now. Complicated may not be the operative word. It gets, it's not necessarily immediately intuitive. So if I have a number line, right? And the worksheet's going to go into depth in this. I'm just giving you a little bit of background on it. And I have, let's say, I know that negative x is, what do I want to say? Negative x is less than 4. Remember, when we're reading an inequality sign, we read it from left to right. So if the smaller, the pointy side is to the left, we say less than. If the pointy side is to the right, we still read it left to right, and it's greater than. Okay. So here's negative x, and it is less than 4. So if negative x is less than 4, then what is the opposite of negative x or positive x? And I'm sorry, I messed that up. Let's call that negative 4. So this is also, I'm missing all this. Okay, start over. I'm not going to start the video over, even though I just started, because I think it's important that we understand that math is a struggle, and that concepts, even for someone who, like, my math goes far beyond this, and this is still really confusing for me. I understand it procedurally, conceptually, it's tough for me to wrestle with. And so I'm going to leave it so that you guys don't feel like, why is this stuff so easy? There's nothing easy about this stuff. So I'm going to say negative x is less than negative 4. Okay, so here's my negative x. It's right on negative 4, and it's less than this. So what is regular x? If negative x is less than 4, then what is regular x? Well, if I multiply both sides of this by -1, that's going to turn the negative x into a positive x, right? If I say negative x times -1, that's going to give me the, oh, that's goofy, sorry. That's going to give me a positive x. Well, that's good. Okay, so that's what I have down here. And whenever I do to the right side, I have to do to the left side. So I'm going to multiply the -4 by -1 also. And that's going to give me a positive 4. It's going to give me a positive 4. So I have a positive 4. It's going to erase some of this stuff here to give myself a little bit more space. So I know that at this point, I know that my x, my opposite of what I was given, right, is going to begin at positive 4. But is it going to go to the right, or is it going to go to the left? My instinct is it's going to go to the right, because I'm dealing with the opposite of. So if it's the opposite of left is right, right? So let's just do an experiment and see. So I'm going to say it's greater than. I'm going to say, let me rewrite this a little bit so that we understand what's going on here. So this first one I wrote, I said, we can go with that, that's fine. This first one I wrote, I said negative x is less than -4. And the second one, I hypothesized that x, positive x, the opposite of negative x, is greater than a +4 because I multiplied both sides by -1. Okay, so this math should be pretty straightforward, how I got from negative x to positive x and from -4 to +4. But the inequality sign shifted. So let's look at why that might have been and if indeed we were right. So if this statement is true, then anything for which this statement is true, this statement also must be true, okay? So this would say that x can be 5. Because 5 is greater than 4, right? It falls on the set of values for which x is greater than 4, x is equal to 5. Does it fall on this value? Well, if I plug in 5 here, I'm left with -5 is less than -4. Is that a true statement? Remember, we're not looking at absolute value when we look at the number line like this. We're looking at the actual value. Is it to the left or to the right? And here's my -5. Boom, right there. So yeah, it's true. So here's the rule that you can just kind of remember. Whenever you're multiplying by a negative number, when you have an inequality sign, you have to switch the actual inequality, all right? Another way of looking at it procedurally, with this is a less visual way of seeing it, but for some people it works. It's easier to remember this way. If I use the subtraction property of equality to move this negative x to the right, now why would I do that? You say, well, I'm going to do that. So look, I'm just going to add a positive x. I'm doing that to get rid of the negative sign without having to multiply, because the multiplication confuses me. It doesn't, but let's say hypothetically it does. So I added a positive x here and I added a positive x here. I used the addition property of equality, or inequality, I guess as the case may be. X plus negative x goes to 0. And now I'm going to use the addition property of equality again, and I'm going to add 4 to both sides to get that variable all by itself. And I'm left with 4 is less than the -4 and the +4 are going to equal out to 0, and I'm left with just x. All right. So it looks a little bit different. As a reminder, this was the answer I got the first time. X is greater than 4. This looks a little bit different because the x is on the left here and the x is on the right here, but they are the same exact inequality. They're just flipped. If you notice, the duck's trying to eat the x in this case, and the duck's trying to eat the x in this case too. Okay, that was confusing. If you're confused, it's okay. Don't worry. That's the nature of this stuff. We're going to have plenty of chances to learn it again, because the assignment is going to do a deep dive into this. So without further, without me confusing the matter even worse, let's jump in and do the assignment. Unit 3, lesson 3, solving inequalities using multiplication and division. State standard. In this lesson, you will use multiplication or division properties to solve inequalities. Okay. So often in studying mathematics, we examine number patterns. So they are considering the inequality 4 is greater than 1, which is true. Copy and complete each statement at the right by replacing each box with a less than or greater than sign, what happens to the inequality symbol when you multiply each side by a positive number? What happens to the inequality symbol when you multiply each step by a negative number? Justify your reasoning. Okay. Come on, pen. My pen won't work. Okay, what's 4 times 2 is 8. And 1 times 2 is 2. 8 is greater than 2. Boom, boom. All they did here was they multiplied both sides by 2. Here they're going to multiply both sides by 1. I'm going to get 4 and 1. Boom, boom. Here they're going to multiply both sides by -1. So here's the trick, right? -4 and -1. Now don't get confused. The absolute value, the distance from 0 of -4 is in fact greater than the absolute value of -1. But we're not talking about absolute value. We're talking about whether or not it's to the left or the right on the number line. And -1 is to the right of -4 on the number line. Here's my number line. Here's -1. Here's -4. -1 is greater than -8, -2, -12, -3. Boom. Okay, so what do you notice? What happened when you started multiplying by a negative number? I'm not going to type this in the box because I didn't make a copy of this document. I pulled up the original. So pause the video and try to answer this with your own words. And when you're done, come back. I might answer it. Well, the sign switched. Anything like that. That's not maybe the best answer. Like the sign switched. I don't know. Maybe that is the best answer. I'm going with it. The sign switched, right? Here's the negative. We were working with greater than, and then it became less than, for the reasons that we discussed in the introduction. Okay, if you said the inequality symbol changed, you're right, which we did essentially. Check out the multiplication property of inequality below. Okay, so this is going to be a really confusing way of articulating, a really academic way of articulating what we've just discovered. Let A, B, C be real numbers with C is greater than 0. If A is greater than B, I guess in this case they're saying A is 3 and B is -2, then A times C is greater than B times C. In this case, C, which is greater than 0, is 2, and the inequality didn't change. If A is less than B, then A times C is less than B times C because C is greater than 0. And this is the opposite of that when C is less than 0 and the signs do change. So in this case, they're multiplying by a negative number. C is less than 0, so it's negative. So A is greater than C, then A times the negative number is less than B times the negative number, the same negative number. And the reverse of that is also true. If A is less than B, then A times the negative number is greater than B times the negative number. Bottom line, when multiplying by a negative number in an inequality, the sign flips. Actually, if we were to divide in the pattern above, the same thing would happen. The inequality symbol would reverse. And here's kind of algebraically how the numbers move, the reasons why I try to think about it visually on that number line. A division property is going to be the exact same thing. Doesn't matter the size of the negative number, even it could be -1, -½ whatever it is. If you're dividing or multiplying, the signs are going to switch. Okay. Solve and graph C divided by 8 is greater than 1 divided by 4. And they're giving us the hint, multiplied by the least common multiple of the denominator they mean. Well, the least common multiple of 4 and 8 is the multiples of 4 are 4, 8, 12. And the multiple of 8 is 8. Oh, look, there it is, it's 8. So I'm going to multiply both sides by 8. And because I'm dealing with a fraction, I'm just going to put this 8 over 1 so that's a little bit more clear what's going on here. And I'll put a parenthesis here to bracket that off. And this is greater than 1/4. And same thing. Wow, my penmanship today. Okay, so 8 over 8 goes to 1. That's by design. So I'm left with C over 1, which is just plain C. This is greater than, when I'm multiplying fractions, just like I did here, I'm going to multiply my numerators. 8, I'm going to multiply my denominator. 4 times 1 is 4. And I'm left with 8 over 4, which is the same thing as saying 8 divided by 4, which I know to be 2. So I have C is greater than 2. If here's -2, here's -1, here's 0, here's 1, 2. I'm going to draw a circle. Is it opened or closed? It's open because C does not equal 2 at any point. If the line was here, then we would do a closed dot, but it's not. And then C is greater than that. So the duck wants to eat everything to the right of that 2. And there we go. Was the least common multiple of 8 and 4 equal to 24 or 16? I don't know. That's a weird question. The least common multiple of 8 and 4, I thought was 8. I guess you can not, I guess maybe they're saying 8 is not a multiple. I don't know. You can leave that one blank. Or you know what? I'm just gonna write it in. So I'm a teacher and I'm allowed. Or was it 8? Okay, so yeah, you can do with that what you will. That's why I didn't make a copy and I edited so I can make these changes as we go. So you try solve, check, and graph -n divided by 3 is less than or equal to -1. Okay, here we go. So the first thing I want to do is multiply by 3. I could multiply by -3, and and that would be a little bit faster, but I'm not going to. I'm going to do it in 2 steps, just purely so that you can see it. And whenever I do to the left, I have to do to the right. Um, 3 over 1 times -n over 3. Those 3's are going to go to 1. I'm going to be left with -n divided by 1. So I'm just going to write -n because I assume that there's always a 1 in the denominator. And this is less than -1 times a +3, which is -3. Okay, so this always confuses me. I technically multiplied by negative here, right? But I didn't switch the sign. I'm not messing with, I didn't it wasn't my chess move to say, I'm going to multiply by a negative number now. The negative number was already there. I multiplied by the positive, right? I put in this +3. So I'm multiplying by a positive here, right? That's what I'm putting into this thing. That's why the sign doesn't switch. But don't worry, we have a way of checking and if we did it all right, because I could have messed it all up. Now I want to switch the signs. I'm going to multiply by a -1. I could use that addition property of equality also and bring the n to the right. That's fine, but I'm not going to do that. I'm going to do it this way first. So -1 times -n, that's a negative times a negative, which will always give me a positive. -3 times -1 is going to give me a +3. And in this case, I did multiply by the negative. That was my choice. So I'm going to switch the signs. The n is greater than 3. 1, 2, 3. The duck wants to eat the n. So it's going to the right because the n is bigger. Now, let's check to make sure we didn't mess this up, okay? When you're checking, the temptation is going to be to check with this number. And you can, that's a good number to check with, but it's not going to tell you if the signs are, if the arrow is pointed in the right direction, if the inequality is pointed in the right direction. To do that, you need to pick a number that's to the right of it if it's greater than, or to the left of it if it's less than. So I'm going to choose the number 6. I'm going to choose the number 6 because it's not going to give me a fraction when I plug it into the original. I'm going to plug in 6 to the original now. So I have -n. I'm going to put in a 6 there. Divided by 3 is less than -1. And this comes out with -2 is less than -1. Yeah. That is a true statement, even though the absolute value, the distance from 0 of 2 is greater than the absolute value of -1. On the number line, -2 is left of -1, so it is technically less than. Good, we're in good shape. We can put the 3 in. The 3 will just tell us if we did our basic algebra right. This will give me -3 divided by 3, which is -1. Okay, so I know that the 3 looks good because I can see that math pretty easily, but the 3 is not going to tell me if my inequality sign is pointed in the right direction. Okay. Okay, what is the reciprocal of -n divided by 3? The reciprocal of -n divided by 3. We take the numerator and we put it, the denominator, forgive me, and we put it on top. So it's now the numerator. And we take the numerator and we put it on the bottom. So it's now the denominator. There is such a thing called the negative reciprocal, where you would actually change the sign. If you had a positive number, it would become a negative. If you had a negative number, it would become positive. But when it's simply asking for the reciprocal and doesn't specify the negative reciprocal, the reciprocal is going to keep the same sign as the original fraction. Okay. Solve and graph 10.68x is less than or equal to 50. Okay. It's being multiplied, so I'm going to divide 10.68. Into both sides. Uh, 10.68 divided by 10.68, any number divided by itself is 1. So I'm left with 1x, that is by design. I don't know off the top of my head what how many times 10.68 goes into 50. So I'm going to use my calculator here. I'm going to find out. I know that 10 goes in 5 times, so I can assume is probably going to be a number that's a little bit between, I want to say 4.5 and 4.6. Yeah, 4.68. So I was a little off in my estimate, but that sounds like a good number to me. Okay. And I'm going to round off to 4.68. Now, which way? This is telling me that 10.68 times x is less than or equal to 50. Do my signs switch? Does my inequality switch? Well, no, because I'm not multiplying or dividing by negative number, so it's going to stay exactly the same. And to graph that, bloop, bloop, I'm not going to be fancy about it. I just need to show that it's to the right of 0. There's my 4.68. X is the set of all numbers that is less than that. Boom, boom. And I made one mistake here. If you found it, congratulations. I do need to color in this dot. Why am I coloring in the dot? Because that indicates visually, graphically, that it's or equals to. Right? That line underneath inequality means the color in the dot, because it can actually be this number. Oh, they gave me a little thing to have done it. Whoops. Oh, well. No, not a big deal. Okay, another example. They want you to practice with negatives now. Okay, I am going to, we've seen this where we've had to switch it. So I'm going to use the addition property of equality just to model it a little differently. If I have negative 5x is less than negative 10, if I add 5x to both sides, a negative 5x plus a positive 5x is 0. I didn't multiply by anything, positive or negative, so the sign's going to stay the same. I'm going to be left with negative 10 plus 5x. This was a very long way of doing it. I'm going to add 10x to both sides. I'm sorry, I'm going to add 10 to both sides. When I combine like terms, my negative 10 and my positive 10, that's going to become 0, and I'm going to be left with 10 is greater than 5x. So let's just for a second compare this with the original. How is it different? How is it different, really? Well, the 10's on the left and the 5's on the right. That's for starters, but that doesn't really do anything. It's not, but they're where they were negative, they're now positive, right? So it makes sense that the sign would shift, because if I had multiplied both sides by -1, I would have been left with exactly this. Only the 5 would have been on the left, and the 5x would have been on the left, and the 10 would have been on the right. But my inequality sign would have still been trying to eat the 10. I'm going to divide by 5. I'm going to divide by 5. And I'm going to be left with 2 is greater than x, which is the same as saying 2 is less, x is less than 2, right? So here's my number 2. I'm going to leave the dot open because it's there is no or equal to sign under it. We're going to maybe do a smaller dot. And x is less than that, right? That means that the duck wants to eat that 2. So this is telling the duck to eat the 2. Go over here, duck, not to the left. That's where the x is, and it's not as tasty. Okay. Okay, so notice that the signs switch themselves by doing the addition property of equality all on their own. We didn't actually have to switch it. It's the variable that switched side when we were working with the addition property of equality. If we had done it with the multiplication, I'm going to divide by 5. I'm going to divide by 5. -5, forgive me, yikes. This is next. This is a 2. Negative divided by negative is a positive. Because I'm dividing by a negative, I do need to switch my signs. I have x is less than 2, which is the exact same thing as saying 2 is greater than x. Okay, moving on. Well, that's it. We're done. All right, you know the drill. Do the practice, do the discussion, do the quiz. Once you're done with the quiz, come on back. Let's take a look at it. I hope it's going well. Okay, you back? You did the quiz. How'd it go? Did you find it hard? Did you find it easy? Did it take you a long time? Let me know what's up. Ooh, this one's really tricky. But we're gonna be okay here. All right, so it's saying, let me get some zoom action going on here, and not, yeah. All right. So x is being divided by 3, or x is being multiplied by 1/3. Either way, if I multiply by the reciprocal of 3/1, that's going to give me 3x over 3, which is going to give me 1x, which is what I want. But whatever I do to the left, I have to do to the right. And I'm going to be left with x is greater than -3. Okay, I didn't say to multiply by a negative. There was a negative involved with the multiplication though. And that's the one that always confuses me. I never quite remember. Do I switch the sign if I didn't multiply? My memory says not to procedurally, because I never said, hey, do the opposite of that, right? That was just in the problem already. But let's check. Let's plug in a number that is greater than -3 into that equation. And just so that we have some visual reference, if this is, let's not do that. If this is 0 and this is -3, here's my graph. All right, well, if I've done this math correctly, then my graph is good and I'll be done. But let me just check. So what number can I choose? Well, -1 is in that answer set, right? So let's try -1. I like that. -1 all over 3. That's -1/3 is greater than -1. That's true. If -1 is here, -1/3 is over here. -1/3 is to the right of -1. So we've done it correctly. Yay. All right. So this is the answer. That's the solution. And here is my graph. That's all you really need. Okay, solve and graph the inequality. 1/4, -1/4 of m is less than 2. Okay, so I'm going to multiply by the reciprocal of -4, not the negative reciprocal, this is the regular old reciprocal, right? And what is the reciprocal of -4? It's 4. I make my denominator my numerator, and I make my numerator my denominator. And this needs to be negative. And whenever I do to the left, I have to do to the right. So I'm going to multiply this 2 by -4/1. And I'm gonna see what I get. So 4/1 times 1/4 is 1, and negative times negative is a positive. I'm left with m. 2 times -4/1 is -8/1, which is -8. And in this case, I did multiply by a negative, right? I did that. That was me. So I'm going to switch this inequality sign to a greater than, and m needs to be greater than -8. So this is my solution. Let's graph it really quick. Here's my number line. I'm going to put 0 to the right because I know I need to go to -8 here. I'm going to draw an open dot because it's not or equal to, and then it's greater than, so the arrow goes to the right. Okay, so did I do this correctly? Well, let's see. I'm not going to use -8 to put into this equation because that's not going to, I'm pretty sure I did my arithmetic correctly. What I'm confused about is if I drew my, if I got my inequality sign correctly. So which number is true here? Well, the 0 is true. So we can try that, okay? -1/4 times 0 is 0. Is that less than 2? It is. I could try another one, like if I say -1, -1 times -1/4 is +1/4. Is that less than 2? Yep. So we're good. We're good. If I go to, let's say, -12, like way over here, -12 divided by this negative, or multiplied by this -1/4 is a +3, and that is not less than 2. So there's another indicator that I'm right, right? Sweet. Okay, let me get rid of some of this guesswork here. So this is my solution, and this is the graph of my solution. Okay, so solve and graph the inequality. 2 more to go. Solve and graph the inequality. Negative n all over 7 is greater than or equal to 3. So they're varying it up a little bit by giving us the or equal to sign. I'm going to change my color as I choose. Okay, what is the reciprocal of, if I'm multiplying this by 1/7, we can say, what's the reciprocal of that? Well, 7/1. So we're going to multiply this by 7/1. I'm going to use a negative number here so that it becomes positive, and I can do it in one step. Yeah, I think we could say that. Oh, that's interesting. I'm just realizing something as I write. I just learned something new. This is the point at which we should switch it. I am now multiplying by a negative number, right? I impose that negative number in there. I impose that negative number in there. This is no longer a true statement. This is the point at which the inequality switches. Okay, -7/1 times -n/7. This becomes a 1n. That's by design. I'm not going to write the 1n because we always assume it's there. This is just the number -7. This over 1 I just put in to emphasize that I'm multiplying by fractions here. So -7 times 3 is -21. And that's my answer. N is less than or equal to -21. So we'll do the same game here. Here's my 0. I'm going to put my negative 21 over here. Less than, so the arrow is going to go to the left, indicating that for any value to the left here is and could be that. And now I'm going to color it in. Why am I coloring it in? Simply because the inequality reads n is less than or equal to negative 21, right? What's the or equal to part? It's this line right here. Okay, so let's check. If I were to plug in 0, would this be true? Well, 0 divided by negative 7 is 0. 0 is greater than or equal to 3. It's not. And that's what my graph indicates. And that is what my solution indicates as well. So that's good, right? I just, and let's do one that's true. I'm gonna not choose 21 because I want to choose something that's further into the answer set. But I do want to choose a multiple of 7, so my math a little bit easier. So I'm going to choose negative 28. Notice the negative 28 is n, but there's still a negative out here. So what is this? Well, 28 divided by 7 is 4. Negative gives me a positive, so this becomes positive 4 greater than or equal to 3. And indeed, that is true. Okay. Clear all drawings. So your nephew rakes leaves, going on to number 4. Your nephew rakes leaves in your neighborhood after school and earns $6.50 per yard. How many yards will he need to rake to earn at least $52? So he wants to earn more than that, right? So I'm going to say, well, this is how much he makes. $6.50, right? Inequality model solution. $6.50 per yard. This language is really confusing. It says at least, so our temptation is always going to be to write the at least sign. But that's not what it is. We want to make more than that, right? It doesn't say make no more than 52. It's at least that. So I want the duck to eat that amount that he's making, which is $6.50 per yard. And then 52 is a number that he wants to make more than. Sometimes if you were to write the 52 in first, it would make sense to do this. 52 is less than the $6.50 per yard. Either one of these answers is acceptable. They're saying the exact same thing. This is called the reflective property of equality or inequality. Reflective, like a mirror reflects. These are the mirror images of each other. Okay, but I'm missing one small point. If he makes exactly 52, will he have satisfied this real world scenario? I think so. If the idea is that he makes at least that, and if he walks home with $52, he's good, right? So I need to include the or equal to sign. Okay. Now you can solve this. You can absolutely solve this and figure out how many yards he needs to is he mowing? I'm sorry, how many yards of leaves he needs to rake. 52 divided by 650 is 8. So he needs to rake 8 yards of leaves. Which kind of doesn't make sense to me, but whatever. I feel like it should be square yards, but that's okay. Why am I saying that? Oh, the question's not necessarily asking you to solve it, though. It's asking for an inequality to model this situation. So I'll accept 650y is greater than or equal to 52. In fact, I almost think it's a preferable way to phrase it because it actually models what's going on versus the y is greater than or equal to 8. It's maybe a little bit less clear what's happening. But I don't know. I would have to look at the answer key to see what they want. I'll certainly give you credit for either one of these solutions. Okay. That is it. We have 2 more lessons in module. Let me stop share for a second. We have 2 more lessons in module 3 to get to, so 2 more inequality guys happening, and then we'll get into module 4. And if you're happening to like be close to the recording, that's it, because module 5 is already done. So we are, as of today, 9 lessons away from building out this entire course. So thank you for coming along for the ride, and I will see you for module 3, lesson 4. Bye.